All right, let's go get started. Let me get the lights at least somewhat adjusted for the first little bit. Okay, here we go. All right, so first off, let me get the sign-in sheet passed around. I'll get that started with you. Okay, so while everybody's getting settled in and getting logged in, I'll go through a few quick announcements. So I'm going to spend a little bit of the first part of class talking about the solution for homework number 3. All the grades are posted. And by and large, I'd say everybody did, for the most part, pretty well. But there were a few little things that really tripped everybody up. And I wanted to review them to make sure everybody's clear on what's going on. Because one of the things with these Excel assignments is I'll say they get more and more rigorous. So I want to make sure that you understand the first one, because if you have trouble with the first one, I don't want that to lead to trouble with the second assignment or the third assignment or what have you. Other than that, I got to be honest, I really don't have too many earth-shattering announcements. We have homework 4 that we're working on right now, which is due on Tuesday, or next Tuesday, I should say. We've got our first celebration of learning next Thursday, so the way this will work is on Tuesday, once you all turn in your homework assignment, what I'll do is I'll come into class with a set of exam review notes. We'll talk about what's going to be on the exam, the format of the exam, so you all know what you can expect on Thursday. And then you come in ready to ask literally whatever questions you want. And that's sort of the point. I want to do my best to address all of your concerns. I might have to leave a little bit early because of a meeting I have in Corbly at 9:30, but I'll do my best to make sure that I've exhausted all your concerns. All right, sound good? Okay. All right. So before we get into the in-class exercise today, I want to talk about some of the minor issues associated with homework 3, and specifically, I want to talk about this. Okay. So this was the second problem, which was the problem associated with conditional formatting. Okay. Now, to be clear, the point of the problem was to use conditional formatting. Okay. There was a lot of people that went in and literally just said, okay, all the cells that are between 6 and 11, let's just use the paint bucket and make them yellow or something like that. And so it looked correct, but it's not. Okay. Now here's why. Okay. If you go to the assignment, okay, let's pull the assignment up real quick, and I want to read the rules. Okay, so we're conditionally formatting the table such that the following is true. So let's take the first indication. The first indication says that any cell with a value larger than 11 is green. Okay, well, watch this. The point of conditional formatting is to reflect the current values that are in the cells. So the only values in this table right now that are larger than 11 are these 3 right here. But watch what happens if I take this cell, let's say this one right here, and I make it 46. Bam. It turns green. It automatically updates. Do you see what I mean? If you use the paint bucket to just manually color these, that won't work. Okay? So that's sort of the easy way to check to see whether or not what you're doing is right. If you take this value and make it 7, it automatically recognizes that it's between 6 and 11, and it formats it yellow. Does that make sense? That's the point of using conditional formatting, so that it updates. I mean, I used the example of a grade book. You know, well, I might have a conditional formatting set up for the grades in everybody's class, and let's say somebody's got a C in the class, but then exam 1 comes around and they blow it out of the park and get 100 on it. Well, then that C might be an A after the first exam. But once I input the grades for the first exam, I want the formatting to update accordingly, so I know that, oh, no, you don't have a C anymore, you've got an A. If I use the paint bucket, it's going to still look whatever color I used for C's, and that wouldn't really work out for you, would it? You see what I mean? So the whole point of the conditional formatting was so that it would update in the presence of new values. Okay, and if you use a paint bucket, that won't work. So we took off, you know, a little bit if that's what you did. Now, I will say this, there were some students that actually did the conditional formatting absolutely correctly, but instead of changing the color of the cell, they changed the color of the font. And as long as the conditional formatting was done right, we actually gave them full credit for it. That wasn't the issue. We were really more concerned that the the table was formatted and would update appropriately. Everybody okay with this? All right. The only other things I guess I would point out is there were some, I don't want to save changes to that. On the in-class exercise, I don't want to say we were harsh or anything, but we were sort of, I guess, a little stringent on the format at the end. In other words, there's a few people that actually didn't have the borders drawn on their cells and things like that. And I don't want to say we were harsh, but we really wanted the submission for the homework to literally match the end of that exercise. So if it didn't match, we were kind, but we docked accordingly. But other than that, I think everybody kind of got the gist of what's going on with the exercise. Does anybody have any questions at all? Everybody okay with all this? Okay, all right. If that's the case, I want to talk a little bit about what we're going to do for in-class exercise 2. So the first thing I'm going to do is I'm going to pass this out. I've got a bunch of handouts for this exercise. So let's see, I got 3 here, 3 here, 4. There you go. All right. So I'm curious, how many of you are either in or have already taken like Physics 211? All right, so we got some folks in here. All right. So one of the most classical problems in physics is the projectile motion problem. So you have some projectile. It could be a golf ball, a cannonball, a marker in this instance, and you take that projectile and you launch it. Okay. Now what it does is it follows a parabolic path throughout the air. Okay. Now the path that projectile follows is a function of a few things. Number one, it's a function of the acceleration due to gravity. In other words, if I did the exact same thing here on Earth versus here on the moon, I'm going to have a different motion because there's a different acceleration due to gravity on the moon than there is on Earth. Okay? Now for us, that's a constant. We take negative 9.81 meters per second squared. Okay? So that's the acceleration due to gravity. There's also a few other parameters. For instance, if I toss this marker, its path through the air is a function of where it launched from. In other words, if I take this marker and I toss it and I let it go right here versus if I let it go, let's say, up here, even if I've got the same velocity and the same angle, because I'm launching it from different places, I'm going to get a different motion. Oh, everybody get the sign-in sheet? All right, I'll leave it up here in case anybody missed it. All right. So it's going to be a function of gravity, it's going to be a function of its initial position, and it's also going to be a function of the quantities associated with the throw. You know, how fast did I throw it, and at what angle did I throw it? Now, when you take Physics 211, or you probably do something like this in the first couple days of dynamics, you'll define the following expressions. So a lot of this is pretty basic stuff. When you're in Physics 211, this should be pretty familiar if you've already had the course. So here's the projectile's motion throughout the air. So again, if I take the marker and I throw it, that's what this curve is doing, is showing what the projectile looks like as it goes throughout the air. So to define that curve, I need a function for x and a function for y. Now the function for x is right here. Oh, guess my pen doesn't really like this screen. So the function for x is the one right here. Maybe I can use my little, I can do that. That's my function for x. So it's the initial position plus the x velocity, or the x velocity component times whatever time. So the x position sort of just goes linearly because it's not really affected by gravity. The y position, however, is, and that's where, this is what generates our sort of parabolic path throughout the air, because we have that gt squared. That's how we get that parabola. Okay, so these two expressions right here, these are going to be the ones that ultimately will allow you to plot this parabola that you see here on the right. Okay, these remaining three, like this one or these two and these are really intended to help you with things like, okay, what is the what is the position right here? So what is the time at which we reach the maximum height? how far over is it, and how tall it is. So ultimately, this is all very plug and chug. I'm not intending this to be a physics lecture. I'm intending for this to be a use of Excel lecture. Okay. So what we're going to do is this. Using this set of equations, okay, we're going to use Excel to develop a projectile motion spreadsheet. In other words, based on some given inputs, I want it to tell us how high the projectile is going to go. I want to be able to plot its motion, and etc. So in terms of theory, here are the equations that we're going to use. So honestly, if you take these equations and compare them for what you're doing on homework 4, you know, that first problem, these equations are a lot simpler than some of the stuff we're doing on homework 4. I mean, we got fractions and exponents all over the place. This is pretty basic stuff. Okay. Now, let me go through some of the parameters associated with these equations. So, for instance, t, that is time. It's the time since launch. So, in other words, as soon as I take this marker and I throw it, as soon as my hand lets go of the marker, that's time at 0 seconds. So, you know, imagine you've got a stopwatch, and as soon as I let it go, you hit go, and that's time going through the air. Okay, so t sub max, that's the total launch time. That's how long it takes from it leaving my hand to when it hits the ground. And then I've got the x position and the y position. So x of t and y sub t is its horizontal and vertical position as it's moving through the air. Okay? X sub naught and y sub naught are the initial positions, and x sub max and y sub max are the maximum positions on each end. Now, one of the things you'll notice about this assignment is everything's pretty kind in terms of units. Okay, we're not getting nuts on unit conversions as well. Everything's in meters or seconds or meters per second squared, so you don't need to worry about plugging a value into an equation and then, oh, by the way, we got to do unit conversions. It's just plug and chug, so that'll make this a little easier. Now, a couple things to note. So we have our initial velocity, which I got a little typo there. It's supposed to be I-N-I-T-I. I can't spell yesterday or something. Our initial velocity is in meters per second, but we've got to take this initial velocity and split it up into its x and y components, which you all should know from trig is, you know, the velocity times the cosine or velocity times the sine. That'll split it up into its x and y components. Is everybody okay with that? I mean, do I need to go into the trig, or is everybody all right with that? Am I good? Okay. All right. And then gravity. We're going to take gravity to be negative because if I let go of a marker, it goes down. Okay, so we'll take gravity to be negative. Everybody good? Okay. Now, before we start going into Excel, I know some of you have already started to pull up the spreadsheet. Let me make a couple points. So, we've already dabbled, if you will, in the use of some Excel functions, right? For instance, in some of the exercises we've done in class, we have used the sum command. You know, equals SUM of some range, and it will take the sum of that range, or equals average, and it will take the average of that range. Remember us using that? Well, we're going to need to use some additional functions in order to complete this exercise. So one of them that we're going to need is radians. Okay? When you calculate a sine or a cosine or a tangent or any trig function in Excel, Excel automatically assumes that the value that you're entering is in radians. Okay? So if you enter in an initial input of, let's say, 30 degrees, before you take the sine or the cosine of that quantity, you need to convert to radians. So there's an easy way of doing that in Excel. You literally just hit equals radians and it will convert. If you wanted to do the flip side, you can say equals degrees and it'll do that as well. Okay? Now that's converting to radians. Sines and cosines, that's simple. You know, just equals the sine of equals the cosine of. And then we're also going to need ABS. We're going to need the absolute value of a given number. Okay? Everybody all right with that? So absolute, if you got a negative quantity, that'll automatically turn it into a positive quantity. Sound good? Okay. Now, let me explain one thing. I see some of you are already starting to get trucking with this, so let me explain what's going on. All right. If you look at your handout, okay, so you're going to open ICE2 on Blackboard, which I see some of you have already started to do that. If it's giving you trouble, make sure you hit the button on the top that says Enable Editing so you can actually go in and start entering quantities. Let me be clear on something, okay? So I'm going to pull up my completed one. Here's my completed one. Now, let me show you something. Okay? So the first thing that I do is I enter in some input. Okay? So if you notice, my gravity term is in negative 9.81 meters per second squared. My angle is in 30 degrees. My initial velocity is 30 meters per second. And my initial x and y position are 0. Now, that's the input. Okay? See right here where it says 0.524? Okay? That does not mean go into this cell and literally type in 0.524. That's wrong. Okay? The reason why that's wrong is because if I go up here and change the angle, instead of 30 degrees, let's say I want that to be 20 degrees, I want the computation down below to update. Okay? So just so everybody's clear, okay, everything that's in this box right here that says input parameters, those are just numbers. Those are just going in and entering in values. Okay? Everything below that, where it says computed parameters, you shouldn't have like 25.98 typed in or 0.524 typed in. You should literally be computing the values. Okay? Everybody all right with that? Any questions? All right. So what I want you to do is this. I want you all to go ahead and sort of chug on your own for a little bit, and I want you to see if you can get this filled in right here. So I'll go ahead and highlight these in. I'll highlight those. I want to see if you can get those done on your own. I'll be around and walking around, but right now I want to see if you can get those done. All right, so go ahead and get to work on that. So you are going to have to flip back and forth a little bit between what's on your sheet. And again, I'm here, so if you got any questions, please feel free. Get this to you. Again, the big thing with those computed quantities, you're not typing in numbers. You should be typing in formulas. I'll help you out with the first one. I'll go ahead and hover over it. But the next one, I want to see what you all can come up with on your own with these. So the first one should be equals radians of C5. And you can toy around with it. Change the angle and see what happens. Again, the whole point of this Excel exercise and using Excel in general, be able to change one of the inputs and automatically get a new value. Okay. And I'll tell you, for instance, for all these formulas that are listed, every single one of them is on that sheet in some fashion or another. Every one of them. There you go. There you go. When you get finished, make sure you have an equal sign. Yep. Yes, sir.
T sub 0 on the font value.
Mm-hmm.
I mean, I just got to start at 0, right?
Yeah.
Exactly.
Yeah, because the idea, yeah, I can see you're sort of tracking my head. If you change those, then it would change it. Yep. There you go. That's, yeah, some of you, I think, are noticing when you take your sines and cosines that you can't take the sine and cosine of that cell that reports the 30 degrees. You have to take the sine and cosine of C11 because C11 is the quantity in radians. Okay. Now, one of the things to point out, again, don't take, like equals radians of 30 or sine of 30. No, 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 no. Refer to the cell so that when you change the quantity in that cell, you'll update your formulas accordingly. All right. Now, are some of you getting some like hashtags showing up in your cells? Some of you getting that? If you're getting that, it's because I might have been a little crafty and left the number formatting a little off. So you can go back to some of the stuff we've done before to reformat that. I'm mean like that sometimes, aren't I? Anybody need help? That's what I'm here for. Yes. Okay. All right. That's a good question. All right. So question. All right. So real quick, we have a question on Tmax. For instance, getting a negative quantity. An easy way of fixing that is to that's where the absolute value comes into play. The reason why that's coming out the way it's coming out is because we're treating, like ultimately when we do our plot, we're using gravity as a negative quantity, as a negative number, but we know time, that won't come out that way. So an easy way of fixing that is to do one of two things. Either put a negative sign in front of that or just absolute value, because we know the time's going to be positive. That work out? All right, so that's a good question, and I wanted to bring that up for everybody else. So if you want to hold off on the steps part where it says number of points in the chart and number of units per time, you can hold off on that. That's no problem. But I'm more interested right now that these computed parameters are correct. So. Again, I'm here, so if you got any questions, don't be shy, please. Yes, sir. All right, hold on. So here's how you compute the velocity in the x direction, right? So it's the velocity times the sine of that, or cosine of that angle, and the velocity times the sine of that angle.
For the velocity, would it be for the first one?
Well, let's take x one first. Let's just take it one at a time. Let's start off with that one. Okay. So the velocity in the x direction is v naught times the cosine. So where's v naught?
V naught is up here.
Right there. So you'd say, all right, equals. You could type in C6, or you can just be clear. You can do this. You can literally use your mouse and just say, once you've got your formula started, just say that. Okay. You don't need. I don't think you really need the parentheses for right now. But
okay.
So V6 or C6 times what? You tell me what to write. And we're calculating VOX.
Oh, that here would be cosine theta.
So you tell me what to do.
Cosine theta. Cosine.
Now what theta are we going to use?
Would be in radians. So
There you go. Yep. And then close it up. There you go. Now when you change these input parameters, it'll be reflected down below. All right. All right. You've got actually, let me see something. I hope I don't have a typo. Oh, I have a typo. I have a typo. So, no, I don't. No, I don't. I'm right. Boom. Hold on, wait. Marker drop. I don't have a microphone, so I can't do a mic drop. So I did a marker drop. I'm a dork. It's okay. All right. Let me see something. Okay, that's right. What did you get on it? Do you have? Where's your the formulas? The like where? Let me see something. I guarantee you what I know what it is. It's these right here. Did you have those on your sheet somewhere?
I had them, but then I moved the...
That's probably why, because the TA didn't see what it was. So we can talk a little bit after, all right? We'll sort of we'll see what we can do with that. Sound good? Anybody got any questions? All right. Has everybody gotten the yellow cells done yet? If you haven't, no big deal. I mean, we'll work on this together. All right, are you good or?
I'm just a bit slow.
No, it's fine. It's fine. You got a question? No, it's fine. It's fine. It's fine. If it's your first time doing this, it's no big deal. I mean, that's why we're here. You got a question? Y'all get over here? Y'all get over here? Y'all get over here? You don't have to worry about that. No, no. Not yet, at least.
Do you want these in any decimal place or
No, I'm just worried that I'm just interested if the formulas are right. So.
I tried to change this to see if I was right, and like I did the formulas, but nothing else.
Let me see something. Right here, here's your problem. So, like, see where you have radians of 30? It wouldn't be radians of 30. It would be radians of C5. And then now, if I do 30, now everything should update. So you might want to go through and check all of your other formulas to ensure you're referencing the cells and not the values. Same thing with, like, gravity and all of that. Okay, all right. So the velocity in the x direction is v naught times the cosine. Okay? So here's v naught, right? Now you got to multiply. What's that?
C6.
Yeah, okay. So now you got to multiply times the cosine. So your Excel function for cosine is right here. Okay, so we can say C6 times the cosine of some quantity. Okay, it doesn't matter if you use all caps or not. Now, what's the quantity? Where's your theta? You tell me. What's that? No. Say it again. I couldn't hear you. Remember, when you take a trig function in Excel, it's automatically going to assume it's in radians. So you can't use this one because that's in degrees. You have to use this one. So there you go. The big thing is don't type in 30 or 0.524. Type in C11. And then there you go. Because now if I take this and I make it 15, now everything else updates. So that's the whole point. Yeah. I'll explain that here in a little bit. But yeah, there's purposely a blank there. Okay, all right. Let me make sure I'm getting my formula right. Okay, all right. So let's see how you're entering that. So go ahead and try and enter it. Let's see what you got. Equals. Now, one thing before you start typing, you know you can go ahead and literally, like as soon as you hit equals, you can do that. It'll fill it in. So you don't have to type in the C7 minus. Now, what I would do is this. Where you've got the VOY squared, I do a left parenthesis like that, and then do VOY squared. So that, whoop.
Sorry.
No, that's fine. There you go. And then squared, that's that There you go. Now divide it by. Now here's the thing, okay? When you're dividing, you're not dividing by 2, you're dividing by 2g. So I would do another parentheses. And then 2 times g, which is, yeah. And then you can close that. There you go. Yeah, it was probably the bottom one. Yeah. Yes, sir. Oh, goodness, I'm sorry. Well, we're not, hold on, we haven't gotten there yet, but scroll up. So, okay, so we're not there yet, but if you want, ultimately you're going to do this, like take the first one and then add
That's what I did.
that. But, got to lock that in.
Okay.
Yeah.
Okay, so the first one, equals 5 times 6.
All right. So first off, okay, so let me hit escape on this. All right. So first off, you're not taking the cosine of the velocity. You're taking the cosine of the angle, which you've got that right. And then you can take that and multiply it by that. That was the only thing you needed was that, because we're going off of that right there.
Okay.
Yep. So that's this one. So this one's just going to be the same thing, only it's going to be the sine. Sound good?
Yeah, thank you.
Oh, no problem. All these calculated? All right. You good? You good? Okay. Whoa. Oh, you got a lot going on. Okay, hold on. Here, hit escape. Hit escape. Like just right there. Okay. Move over for a little bit. Let me try to see this one. Okay, all right. Here's the problem. I can tell you right now what the problem is. Okay, so watch this. I'm going to ignore all the absolute values, and I'm going to repeat what you did. So you did equals, why not, minus this squared divided by 2 times that, right? But here's the thing. The way this is reading, it's dividing by 2 and then multiplying by gravity. What you want is to divide by the whole thing. That'll do it. You see what I mean? Stuff like that. I mean, think about this as you're doing this assignment, but then go back to homework 4 and go, am I doing this right? You see what I mean? All right. Okay, has everybody gotten all of this, or is at least on their way to getting this? All right, so if everybody could, I want everybody to watch up here because I want you to see what's going on for the next part of the exercise because I want you to understand. Now, hold on, let me say this. I've had a couple people ask about this right here, this problem 3 blank right here. I left that specifically there for a reason. If you go to homework 4, the problem 3 is saying basically complete this exercise, but it also has a question regarding solver, which we're going to cover next time. So this will be where you put your answer in for the homework. So you can ignore this for now, but it'll make sense later. All right. Now, I want to explain what's going on for the table down below. So everybody pay attention so they understand. All right. So when we plot this parabola, okay, the way that Excel works, it's got to have a number of points to plot. So the idea is this. The more points, the better the graph. Okay? So if I picked, let's say, 10 points on the graph, so I've got my parabola, and I go, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll get, a picture. But if I picked 100 points, I would get a more accurate picture. The more points, the better accuracy of the plot. So for the purposes of this example, I'm just going to say, you know what, 20 points is good enough for government work. So we'll say we'll have the steps of 20 points. Hey, I'm a civil engineer, so I use that statement quite a bit. All right, so we'll do 20 steps. Okay, so 20 different increments essentially along that curve. Now, I want to reference this quantity right here. This is 3.06. So 3.06, what that means is that based on the input that we've provided for this example, the moment that I let go of the marker and it flies through the air, based on this input, it's saying that it takes 3.06 seconds for this projectile to make its journey throughout the air and hit the ground on the other end. So in order to plot this, I'm taking this point and this quantity, and I'm divvying it up into 20 points. Okay. So if I take T max, which is the total time, and divide it by 20, that means I'm going to have a point for every 0.15 seconds that the projectile moves through the air. All right. Does that make sense? Okay. Now what I'm going to do, I'm going to clear out my table because I've got it completed right here. So I'm going to delete the chart. I'm going to clear up my table. All right, I'll delete that. So yours should look something like this. Am I right? That's what yours looks like? Okay, all right. So I'm going to help you out with the first column, and then you all are going to do the rest. Okay, so watch this. We're going to start off at a time of 0. So you can literally type in the number 0 right here. Okay? And then I want points plotted every 0.15 seconds. Now, I'm not going to do this. I'm not going to say, 0.15 and then 0.3 and do that. I'm not going to do that. Okay? I want to reference this cell right here. So I want you to think about this. Every row that goes down, I want it to increase by that much. So watch what I'm going to do. I'm going to say this value right here, it's got to equal that plus that. Does everybody see that? Everybody okay with that? So the cell below that is going to equal that plus that. Do you see what I mean? You see how I'm doing that? So every row below equals the row above plus this. Okay? I'm lazy. I want to copy and paste all these cells down. What's the problem with the way I've entered the formula so far? I didn't lock something, right? Which one do I need to lock? C18. I need to lock that step. So I'm going to say, all right, let's go back to this original formula, and let's hover over the C18. And remember, what's my little keyboard shortcut? F4. Bam. Now what I can do is I can take this, and I can drag it down. Remember the hover over that little black corner or the green corner, I guess, in the bottom right until you get the black cross sign, and then drag that down. Okay? And you'll notice it automatically fills in everything. Okay? Now, let me keep going, because I got to keep going until I get to 3.06. So a little bit more. There we go. All right. Does everybody see that? Everybody okay with that? Now, one other thing, this is not formatted correctly, okay? Because if you look at the table, all those values in those cells are centered and they're all boxed, right? So what I'm going to do is I'm going to highlight all of this. Just highlight this whole table. Now watch this. I'm going to hit the center button up here where it says alignment. That puts them all the values in the center. And then see where it says font. I've got bold, italics, underline. This little symbol right here will put borders on the cells. If I click that little drop-down arrow and hit all borders, now they're all bordered up. So when I hit print, the table will be easier to figure out. All right, is that clear? All right, yes, sir.
Yours is like 31, 46, 61.
Right there. That's your issue because you entered in 0.15. Okay. Let me say something else real quick to clear something up. And I didn't mention this before. So your time step, we're not entering our time step by just literally typing in 0.15. We're taking the total amount of time that the projectile traveled, which is T max is 3.06 seconds, and dividing it by 20. So for this cell right here, I'll go ahead and pop this up, it's not 0.15. I'm taking the T max and dividing it by 20. So if I hover over that, that's what I'm doing. I'm taking 3.06 and dividing it by 20. Does everybody understand that? Did that clear yours up? Everybody else good on that? Yep. Oh, go this way. Yep. Really big number for what? Okay. Let me see. Now, did you fill in this cell and drag down? Or okay, this one. All right, so let's see. So C7, which is, oh, so y naught plus v naught y times t plus g t squared divided by 2. That looks right. Let me try something. You've got a number of parentheses, so I'm having a hard time tracking what's doing what first. Let me just try it again. So equals y naught, that times that, plus g times t squared divided by 2. Is there an absolute value I'm missing? Let me check. Hope I don't have a typo in my formula. Okay, all right, let's check a few of your input values, your values up above. Let me see something. So that's 15, 9.81, 30, 30. Oh, that's the problem. That's 0. That did it. The initial input right here was 0.
Yeah, okay.
That did it.
I never used this one before. I think I got it right, but how do I get it to not?
Oh, you're ahead. We're going to talk about that on Tuesday or Thursday.
Whenever I do it, it changes. Like it maxes me out to 15.
Yeah.
Maximum height, not changing that. But I wanted to display in there. Does it matter
Well,
if it changes these values?
well, ultimately, watch this. Ultimately, what I'm going to have you all do is this. What I'm ultimately going to have you do is just take that number and literally put it in here.
Oh, just put it in there.
Yeah.
Okay, that's all I got.
Yeah.
Okay.
That's what. Yeah. All right. Anybody else have any other questions? Okay. Let me show you something real quick. Okay. When you compute your x and y plots, your x and y columns right here. Let me delete the graph. Let me say this. So you are going to compute each of those columns based off of these expressions right here. So I'm going to go ahead and tell you the expressions. Okay, it's those expressions right there. The only thing is you have to be clear on what you're locking and what you're not locking. And I'll give you a hint. So for instance, you're going to take that formula and you're going to copy and paste it down that row. Okay, but one thing that isn't going to change is gravity. Okay, so one of the big things you're going to want to do is make sure that you've locked gravity in your cells. Okay? Now that's gravity. I'll leave you to figure out the rest of them that you need to lock. But when it's all said and done, you should have a table that looks something like this. It should look like that. I'll zoom in a little bit further. Maybe I can get a little bit better. Is that better? Is that easier to see?
There's not a way to set up the goal seek in a specific cell and then reference cells outside of that and then present the value?
You're not really, but not really, no. Because the idea is that you can toy around with your input.
Yeah.
So I know what you're getting at, and not really. Usually what I'll do is if I have a specific value that, like I've goal seeked and I want, just copy and paste and put it somewhere else. Yeah. Now there are some tools like what you're talking about with more advanced techniques in Excel, like statistics, random number generation, things like that. Like I can take a data set and literally hit go, and Excel will spit out mean, standard deviations, and all of that. And it will do it on a separate sheet. So that. Oh, that was my next statement. It's like with macros, you can do just about anything. So. What's that?
What do you want us to find?
I'm wanting you to plot these quantities, and remember, you're using these two equations right here. But again, make sure that you're locking the right cells. Some cells are going to need to be locked, and some aren't. Now, when you use time in those equations, time comes from here. Okay, that comes from that column of time values. All right, sound good? Yes, sir. Nah. That's looking good. You might have something you might want to fix on yours. I think those values here, these look a little large.
Oh yeah, I know.
No biggie, no biggie. Okay, now, if you've got let me show you something else real quick. Let's say you're computing the right value, but it doesn't look the way that you want it to, okay? Remember, you can go into Excel, and then you can highlight these quantities, and then you can say, all right, use these number tools to increase or decrease the decimal. Use the border tools and the formatting tools to center it up and put borders around the cells. You can play around with that however you would like. Again, that's your goal. Again, no typing in values. Everything should be computed at this point. Yes, sir.
I know these big like.
Now that's increase. Go to the decrease.
Oh, okay.
Yeah. Okay, and then like highlight all of them.
All that.
All of it. Now, that one right there. Now it centers it up. Not too bad, right?
Yeah. That's the problem.
You need help or whoa?
I don't know.
Do you need help or do you want me to leave you to it?
I can try to figure it out myself.
Okay, all right, that's fine. I respect that. No problem at all. How's everybody over here? Y'all doing good?
Yep.
Y'all doing good? Awesome. Oh, your graph? The only thing, well, okay, a couple things. So number one, you need to format these so that it matches that. You know, everything's centered up, 2 decimal places. And then as for your graph, like what I would do is just take it and sort of like, I don't know, like put it right there or something so that it's kind of close. And then that's it. Yes, sir.
I was going to say, how do you make a wish as 2 decimal places?
Okay, all right. So again, on the 2 decimal places for the cells, okay, you can highlight all the cells that you want to change. Like these are all the ones that I want to change. And then look at your Home tab right here. Okay, see where it says number? You can mess with all sorts of formatting in this number tab. For instance, this button right here, this one right there will increase the decimal point, but then the button next to it will decrease the decimal point. So you can see now everything went to 3 decimal places. I can squinch it down to 2 here. Now if you've got your column widths fixed and you make it too big, you'll probably see a lot of hashtags pop up or number signs. Does everybody see that? Like if you've got a really big count, what happens if you start increasing your decimal place too far? Excel goes, whoa, I don't have the ability to store that. Or display that, I should say, not store that. Display that.
So these
No, I know. No, I know. But I just wanted you to test these three, and based off these three, figured out. I know that actually experimental or exponential is a little better, but I wanted to keep it kind of simple, and I wanted it to be clear which ones. Let's put it like this. I wanted to keep it simple, but I also wanted to keep it a little challenging because I wanted you to be able to look at those three curves and go, you know what, that one really is the best. I mean, there are some that are better, but there's two ways of making that better, or three ways. One, eliminate your outliers, use different curves, or get more data, you know. So, yeah, if you can't. Sometimes you can't, you know. If you want to go ahead and do your plot, you're more than welcome to. I mean, I'm not going to stop you. I'm just, right now, I just want to make sure that everybody's at least on that square. I am not going to inhibit the learning process. Believe me. All right. Does anybody need any help on the table? Yep. Did it get mad?
Yes.
Okay. It got mad. I can tell you right now, it got mad because of that right there. Excel doesn't recognize that if you take a number and put it next to a parentheses that it's multiplication. You have to actually put the symbol there. Try it now. There you go. Yep.
Why you can't get my X-Max to come out for anything other than 91.7.
Okay. All right. The secret is right here. Now this quantity is correct numerically, but the problem is because we're using this value, and this value needs to be negative for these plots that we do down here. But time, it doesn't make sense for time to come out negative in this aspect. So what I'm going to do is this. I'm going to use absolute value.
So that comes out positive.
Yeah.
I'm not worried about the time. I'm worried about the X-max. I knew how to do the absolute value so it's about.
Well, but the T max gets used in those quantities down there.
I didn't actually use it up here. I'm not gonna lie to you.
Well, here, first off, your X max equation isn't right because this is your X max equation. It's X naught plus VOX times T max. So it should be equals, let me see it. So X naught plus V naught X times T max. Whoop, I did that wrong. I hit my cursor. Times T max. And I hit enter. There you go.
It comes out just fine.
You might want to check your formula on the Y max as well. You good? That you're yeah. Yep.
Okay, I had the right values that it showed, and then I accidentally put this instead of that.
How about this? All right, try your undo button.
Because I kept trying.
All right. Do this. Drop it down. Just hit number. What is up here? Okay. Let me see something. What is going on here? Let's just do general. Whoa, what? What?
I hit these instead of.
All right, here, I'm going to do clear formats. See this right here? That's just sort of, like you can hit clear all or clear formats, and that's just a way of starting over. So try it now. I'll be honest, I don't What's that? All right, is anybody having any issues with the table? How's everybody doing with the table? Okay, yours is good, yours is good, you're good. You're good. You're working on it. You're making it happen. Is your table good or? Yep. Okay.
Are we doing anything for problem 3?
We'll talk about that next time.
Okay.
Yeah. Okay.
So I did that.
We'll watch it. All right. So first off, highlight all of these, the ones that you want to change, and then that one will decrease the decimals. See it? So you can just do that.
I don't know. I think that's what I pushed.
You probably push like this or one of these. I'm talking about this one.
Does it work if you only highlight that box and like this column?
Should, yeah.
Because that's how I got all the number signs. But I probably
You might have hit it. You might have hit like scientific or some odd format in there. Does that make sense?
Yeah.
Yep. Okay, no, you're not locking the wrong numbers, but your time, well, actually, yeah, you kind of are. So here's the equation. Okay, so let me delete this. Okay, so you're going to hit so x naught, right,
C7.
plus v naught x times t. But this isn't t. Okay, you want x to change as you plot. The t that changes as you plot is this one right here, which if you're having a hard time select it, just do C23. Like you want that value to change right there. Oh. What the? What do you have here? Oh, sorry, B23. B23. There you go. So that's the T. Not this, it's that.
Okay.
Now, as for the ones you lock, it's going to be everything up here that doesn't change. So, like that one and that one. Now, and you can, if you're lazy, you can take this and double click.
Okay.
Yeah. Sound good? Yeah. That looks right.
Yeah, but it takes me a while.
That's fine. It's your first time doing it. The only thing is you got to take this, drag it down. You missed one. One more.
Oh, okay. All right, thank you.
How would you use solve?
That's next time. If you're looking at the homework and you see this problem 3 or this stuff related to solver, don't worry, that's coming next time. All right. Is everybody good with the table? All right. Real quick, I want to show you something. So if you're at the point where the table is completed and you're ready to plot, literally, this is all you got to do to keep it simple. You can highlight your X and Y data like this, like literally just highlight it. And you can go to Insert, Charts, and then remember that scatter one. We'll do scatter with smooth lines, and there you go. Now, if you want, you can do what we did last time where you insert a blank chart and literally go in and say, here's my X points, here's my Y points, and there you go. But the point is, look at the chart. I mean, that's exactly what it looks like. I mean, if I take a marker or some projectile and I launch it in the air, that's what it does. It matches that parabola, okay? That's sort of the nifty part. And keep in mind, if you change your input up above, not only will it change the output, but it'll change the chart as well. And everything will be dimensionally accurate. So again, Excel's a pretty powerful tool because we can create a spreadsheet to do whatever we want. Okay? So what I'm going to do is this. I'm going to take this, I'm going to move it right there, and then I'm going to let you all play around with getting your table finished and getting your chart built. Okay, bless you. And I'll sort of leave you all to that. So I'll be around if y'all got any questions on that. As for formatting it, really the only thing you've got to do is change your chart title and add some axes on there to have like X position and Y position. And then that's really all there is to it. Again, don't worry about that blank spot that says problem 3 or that thing on solver on the homework. We'll talk about that next time. All right? So don't worry about that. If you've got your in-class exercise done and you are, let me close this and sort of reopen it. If y'all got questions, I mean, I'm here, so. If you have your spreadsheet looking like this, where you have your chart, you've got all your values, and you've got the projectile motion in a vacuum, you've got all that done, I mean, you can leave if you want, but if you haven't, I mean, I'd try to make sure you get that finished out, and you're going to need it for your next homework assignments. If I were you, I might as well stay here and knock it out. But if y'all got any questions, I'm here, so yes. Mm-hmm.
and it just
Oh.
expanded.
Okay.
I don't know how to fix it.
All right, first off, you're in a different view, and you can go down here. You're in page layout view,
Okay.
like right here. If you do that,
Okay,
you're done.
perfect.
But you can go to page layout, and then literally that button right there. See, anytime you see this button, it'll bring up a sort of a more advanced dialog box. I can go to header and footer, but that's actually already done. You didn't need to worry about that for this one.
All that was, it was like legit, like already done, but then it just
Yeah.
changed
Yeah, it's kind of nifty if you're trying to print because you can literally see what each page is going to look like, and there is some value to it. Personally, I don't use it very much, but there is some value to using it. So.
I have a question about that was made. Like, these numbers were different than what was on like the answer sheet, but he had the same like table that I did. But I had like 10 points, 11 points taken off.
All right. Let me ask you this. Let me see your homework 3 part 1. Let me see your part 1. No, that's homework 4.
I know I got that one. Like these are, if you do that,
So you got these wrong or right? I mean,
just that one.
and you got 10 points off?
Yeah, like so I don't
Okay, I'll tell you what. Let me take a look at it here. Here, you hang out for a sec. Let me write your name down. I'm gonna take a look at it, and it's possible it could just legitimately be a mistake. So, I mean, no, that's fine. That's fine. All right, I have a little mark on yours. I'll take a look at it. All right. Okay. On yours for the formulas. What I can do is this, since you have the solution, like you could literally just turn that in. If you turn that in, I can give you half credit for it. I won't give you all of it, but sound fair? All right. So I'll split the difference on what you got. So just email it to me. So.
I was just wondering, like, is there any way we can find out what we missed on the last homework?
Well, okay. What I see what you're saying there, and I understand that can be kind of tough. What I did was this. On Blackboard, I posted some general comments.
Okay.
The big mistakes that people made across the board were either the conditional formatting was wrong,
Okay.
or I had people who did this and literally just this part right here, the formula part for problem 1,
Yeah.
and just didn't put the answers down. Like we didn't know that you did it, So, but hopefully, first off, let me say this: on homework number 4. I'm hoping that kind of got cleared up a little bit, because on homework 4, I mean, I'm not trying to say it like this, but I literally kind of made it like just put it in there, So,
Okay.
all right.
Sounds good.
But if you got any specific questions, come by and we'll take a look at it. All right.
Alrighty, thank you.
All right. It looks right so far. Now that one right there, how did you get that?
That, I just looked at my graph. You want us to actually plug in the value because it wasn't a prediction. It said
That's what the equation's for. So take the equation that you think is best, plug in 3.75, tell me what you get. Now you're looking at the graph, so the graph tells you it's about 10. So when you calculate it, it better not be 46, or you know you did something wrong. So. All right, I'm actually going to go ahead and stop the recording, because I'm actually just been realized I've been sitting here recording this whole time. So, all right, we'll see you YouTube folks next time.